for this. This fan should overcome the pressure drop in this duct and in this fittings. And here this A terminal means it can be diffuser or it can be slot diffuser, whatever. So you see supply duct, this is a supply duct. Fit in accessories, these are the fittings or any VCD, etc. Then supply terminal, the last supply terminal. And one more point, return air. Why the return is required? Return air terminal, because the unit will suck na. So from where? You see this grill, this salt diffuser for return. So this will also create pressure drop. So this you need to consider. Many engineers ignore this or this means they're forgetting this one. So be careful. Return A terminal you need to consider in calculation to get the ESP, external static pressure. This is case 1. How to calculate I'll show you. It's a simple one, but this case are important. Case 1 is only with the supply duct. Clear online? समझ रहे हैं आप लोग?
Yes.
Now case 2 you can write. Case 2 you can write AHU with.
ये रिटर्न एयर टर्मिनल जो आप कह रहे हैं ये हाइपोथेटिकली हमें वो करना होगा या एक्चुअल में भी होगा?
एक्चुअल होगा ना, because जब when the suction take place through this return only ना, तो return होगा तो that pressure drop you need to consider, take into account in the fan selection. This is for what? Case 1. So only with supply duct. Case 2 you can write AHU with supply plus return duct. So for this let me open one drawing, the same previous drawing, the toilet area supply plus return. Second case you can write AHU with supply plus return duct. Now in this example you see, I think you know this example, kitchen area we use at the starting sessions. Layoff. Now in this case let me explain first. For this selecting the fan for this unit FC or AHU, we need to consider this supply duct. Again supply duct means the critical path. Then this fittings and accessories like VCDs. Then don't write, just listen. Then the A terminal, the last A terminal. Plus you see you need to consider the pressure drop in the return duct also na, this one, right? And the return A terminal. Getting your point? Okay, make a note. So what you have written? Case 2 is what? AHU with supply plus return, right? In that you can write first point, supply duct in bracket critical path. Critical path is applicable for all the cases. First is supply duct. Second, fitting plus accessories. Then third, supply A terminal. Only the last one, only one we are considering, not all. Supply A terminal. Next point, return duct with fittings and accessories. And you see here in this case partly return duct, is complete return duct. In that case again you need to apply the critical path for the return A duct also. In bracket critical path if applicable, like this elbow or any VCD or some bell mouth, etc.
And
then
this one is?
This point you can write return A terminal. These are the items you need to consider for ESP calculation. Next, this is case 2. Case 3 you can write AHU with supply plus return and fresh air duct. So in this case you can write for supply side same as above. Supply means supply duct, fitting, accessories, A terminal, same as above. First point for supply duct same as above. Now we have return and fresh air. So in this case what we'll do, we'll consider the longest between the two. So next point you can write between return and fresh air duct, consider the longest between the two. And remember this fresh air duct is not from FAHU. This is just a fresh air duct from opening at the outside with the lowers. There is no fan attached to this fresh air duct. If it is supplying from FAHU means that fan capacity will consider in FAHU. But this fresh air duct without connected to any FAHU, just for suction from outside. अभी देखो यहाँ पे for example.
यानी outside
फॉर एग्जाम्पल यहाँ पे देखो, अभी ये यू कैन सी दिस रिटर्न ना, यहाँ रिटर्न तो क्लियर है, रिटर्न यू कैन सी दिस रिटर्न एंड दिस इज सील, दिस इज रिटर्न इन plenum. So what I'm going to do, suppose assume that is the outside wall. So from outside wall I'm connecting one fresher duct to this, and here I'm adding one lower, there is no fan. तो यहाँ से fresher सब करेगा, यहाँ से return air. तो ये दो में which is higher, which is longest, or which route with the higher pressure drop will consider in calculation. Okay, so these are the possible cases. Now we'll deal with one example. Calculation is simple, not lengthy, because we already know the concept at the time of pump selection. So here we'll do an example, simple example. First manual, the same example using Excel. Okay, I'll take another 15 to 20 minutes to complete this. Can I continue online for 15 to 20 minutes?
Yes, sir.
So that I can complete this syllabus and the topic and syllabus. Next, so you see an example. Here's a fan with supply 7000 CFM. Simple example. Focus on the concept. Now critical path, you see 0.1 to 0.12, longest route, including this. So in this example, first we'll find out the pressure drop for state duct, and after this two elbows and this A terminal in this example. Okay, and in this example there is no accessories. Accessories I'll cover with Excel, because for accessories we have fixed values for pressure drop. We cannot calculate yet from the vendor. So simple, you see for state duct, and you know this, for fan selection duct sizing is required. So here the duct sizing data for the example is given. So you can find out this friction 0.015. It means it's a equal friction method. Same friction for all this section, 1 to A to B. You see duct size 1 to A to B, the same friction. It means it's a equal friction method. And if you design the duct with the equal friction method, it means the pressure drop you are considering same for 100 feet. So simply if you multiply the total duct length with this value by 100, you'll get the pressure drop for straight duct, right? L into HF by 100, same like piping. So for 100 feet, this much of pressure drop, 0.095 inches of water gauge per 100 feet. And now if you know the duct length, 0.1 to A to B, complete one till this 0.12. So since we use equal friction method, so you see here total length is 175 feet for this example. 175 into 0.09 multiply with divide by 100. 0.16 is inches of water gauge for what? For state duct, first step. Okay, step 1. Next, for step 2, you see in between this longest critical path, elbow 1, elbow 2. So how to find the pressure drop for elbow 1? So let me show you an example with the Ashtray coefficient method. You can use equivalent length method from carrier also, but this is also one option. So pressure drop in elbow. So we required R by W and H by W ratio. H by W means height to width. And if you talk about elbow 1, you see this elbow 1 in between 1 to A, na? So the size of this elbow is what? Same as duct 1 to A. 1 to A size is what? 42 by 18 after duct sizing. You know about the duct sizing. After duct sizing only we can proceed. So now H by W is what? 18 by 42. You can find out H by W, no confusion in this. But what about R by W? W is still width. But what is R? R, remember, inner this is center radius. And you know this, for standard elbow, the inner radius is 6 inch. Or for long run, it's W by 2. So if I consider this as short run, standard elbow, this inner radius standard is 6 inch. If this is 6 inch, from this point, can't you find out this distance? See, up to this is 6 inch. What about this distance? This distance is what? Yes, half of the W, right? Right, so W by 2 plus 6 inch. You'll get R value, right? So the same here. So you see, here you'll find the calculation. W is 42, H is 18. R, how I got this R? You see, 27. How I got this 27? 42 by 2 means W by 2 plus 6, 27. So here R by W. R by W ratio is 0.64. H by W is what? Height to width is 0.42. But why we are calculating this? So remember, after getting this R by W and H by W, one can find the loss coefficient C value. And why the need of C? When you get the C value using the formula, this formula, you can find out the pressure drop in elbow. But how to get this C value? From data book. and this table is taken from ASHRAE data book page number 56. In this table, you see, this is H by W, this is R by W. So H by W we have 1 minute. You see, H by W is 0.42. 0.42 means here H by W, the higher available is 0.5. I'm going to mark this. R by W we have 0.62. The higher available in this is 0.75. Now if you intersect both, the intersection value is C, 0.52. C is what? Loss coefficient. Okay. Now using this loss coefficient, we have a formula. You see, C is a loss coefficient, what we got just now. Multiply with the, in bracket, V. V is a velocity. And from where you get the velocity? At the time of duct sizing. So you need to record the velocity also at the time of duct sizing. So see, 1 to A, velocity is 1500. So here is the V's velocity. 4000 is a constant as per the formula, whole square. When you put the C value in the formula with the velocity 1500, here is the value 0.073. You can verify, I'll share you all these notes. 0.073 inches of water gauge. Okay, so once you get this, so we got this pressure drop in elbow 1. The same procedure for elbow 2, but the dimensions are different. See, here in this route we have one more elbow, elbow 2, but this dimension, this elbow is what? B to C. The dimension B to C is what? 30 by 12. So H by W, R by W ratio will change, and the C value will change, and here you'll get the result 0.043 for elbow 2. So state duct 2 elbows. Now A terminal, you need to consider the pressure drop for the glass diffuser also. But pressure drop of the diffuser you can find out from whom? Under. And I think remember at the time of terminal selection, in example, we did the selection. So we did the terminal selection and with the manufacturer catalog. So from that, you see, already explained this pressure drop value will use at the time of calculation. Let me show you the same again. देखो यहाँ पे total pressure inches of water gauge. For example, if you select this 12 by 12 diffuser, we decide this na pressure drop. You see, for example, 0.096. So you'll get from the vendor at the time of shop drawing. You can expect this accurate values. By the time of design stage, remember we are assuming standard value as 0.1 inches of water gauge for any A terminal. See, 0.1 inches of water gauge. This is like a thumb rule. Now if you add all the values, you'll get the ESP here. You see state duct, elbow, etc. last A terminal. This is the ESP, the total. Now I assume ISP just to complete the calculation. Here you see ISP, what I assume is should drop it is AHU, say 0.75, and in the calculation we got the ESP. So total is going to be the TSP. So TSP is say 1.101 inches of water gauge. Now this ESP you can use in the formula at the time of consultant side. This is not the final value, and after shop drawing you can expect the accurate value, but this is just for example. So CF formula is what? CFM multiplied with total static pressure. This is TSP, not ESP. Total static pressure by divided by 6350, the conversion to get the result in HP, and efficiency factor. Efficiency also from the vendor. So in actual practice, provide these two parameters, the CFM and ESP to the vendor, and they will add ISP to get TSP, and based on their efficiency, they will find out the fan motor HP. This is just for example, this formula. Okay. Got it online? But you see, in this example, we have not considered any accessory like a VCD or VAV box, etc., or a filter. Any filter comes under ISP, but this VCD dampers or this VAV box all comes under ESP calculation. But we have not covered in this manual, so don't worry, I'll cover in Excel sheet. So Excel, I'll take another 10 minutes to complete. We did the manual. Now I'll show you the same in Excel. I'll show you how to use Excel. And in Excel, I'm going to cover this accessories also. Okay. Next. So Excel, you can find out from your data. Excel is simple. I'll take this is interesting and important too, and very simple using Excel. So Excel you can find out from your data under fan selection folder. You see fan selection, year one Excel. This is also not from Azure Career. This is a user prepared only. In actual practice, from your consultant, you may find your own consultant format. Okay, so focus on the concept. So here you see in this Excel, if you want, you can use the same Excel also. But if the consultant already have their own format, follow that. So if you know the concept, you can follow any Excel for fan. So now you see this first section is for state duct. Just understand the format first. Acha, before this is for general information like project name, location, etc. And this is with the standard roughness coefficient for GI sheet, this Excel. And this second section is for state duct. I'll show you how to calculate. Third section is for fittings. You see, these are all fittings, left side. Fourth section is for accessories. And you'll find the predefined values for accessories like a thumb rule. Because you cannot calculate the pressure drop of accessories. Either you need to get from the vendor or at the time of consultant side, you can use this value like standard. Okay, like A terminal, we considering 0.1 standard like thumb rule. But actual value you'll get from the vendor at the time of contacting, means at the time of shop drawing, when you decide the vendor. Okay, now how to use this Excel, very simple. So when you select this section, first I'll show you for state duct. Example, when I click here, red color is the user input. And when I click here, you can find the formulas. Can you see the formulas online on the top? So to use this formula, what I'll do, I'll not delete all this. I'll delete all this because this is one project Excel. So I'll delete all this except this first section. Why? Because I want to use this formulas. If I delete everything again, I need to just add the formulas. Okay. So don't delete all except this first section. Now simply I'll update these numbers based on this, say, same project, for example. Zoom out. You see first section, and in Excel you cannot go for complete state duct like manual. You need to go for section by section. Why? Because as per the section we'll update the fittings also. So first section is 1 to A na? So 1 to A, what are the parameters we'll update? CFM is what? 1 to A online in this example. You can read here 7,000. So update 7,000. After that, update the length in meter. Here 15 feet plus 40 feet. So 55 feet na? But here as per this Excel format, we require in meter. Can you convert this into meter?
3.28. Divided by 3.28.
So you'll get 16 point something. Can you please verify? 55 divided by 3.28. 16 point?
6. Around 17. 16.
16 point?
17 meters.
No, don't round off.
16.7.
Meter na, meter may don't round off. In mm we can round off. Next you see duct sizes. 1 to A duct size, you know, you can verify 42 by, you can find the duct size below na, 42 by 18, right? But this is in inches. In the Excel we require in mm. So 42 if you convert into inch into mm, 42 inches, 42 into 25. So you get what? 1050, right? And 18 inch means 18 inch is 450 only, right? Now when you enter this, directly you'll get the information here. You see, PD, pressure drop per meter, 0.47. This is in Pascal. This Excel sheet is in metric, so this is in Pascal. And as per the length, 7.84 Pascal. Okay, this is for section 1. But now, this is not the end. In section 1, is there any fittings? 1 to A, is there any fittings?
Yes, one elbow.
One elbow. Okay. So what you do now, in the below section, delete all this red color. This is a user input. Now, we can have, for example, this is section 1. And in the same section 1, if any fitting applicable, you need to enter only the quantity. Which elbow? Elbow is applicable. How many elbows?
90 degree.
One elbow, 90 degree, one elbow. So you need to enter only the quantity, that is 1. You'll get the pressure drop for this. You see, cross coefficient, everything. This is a program. So enter the quantity for that quantity of fitting under that same section. Then only the software will use these duct sizes for this fitting. So be careful. Okay. Next, A to B. A to B, I'll copy this format to copy the formula. Copy, here paste. Now, then A to B, can you find out the CFM online?
Yeah, 2400.
No, A to B. 7,000 minus 2,400. 4,600, right? 4,600. Next, length. Length is 20 feet only. 20 feet means convert into a meter. 6.09. Okay. Next, you see sizes. A to B. The A to B, that size is what? 30 by 18. 30 means what? 750, na? 18 means 450. Now you see you'll get this pressure drop for that. Now any fitting A to B? No, there is a T, na?
Equal T, yeah.
There is a what NT, not trans T or straight T. And this T I'm considering here. This T I'll consider in B to C. Because we consider only at one, this fitting we are considering A to B. Similarly, this fitting I'll cover in B to C. So I'm considering, you see, under the same section, find out NT quantity 1, means straight T. The same you can proceed for B to C and so on. Right?
Yes, sir.
The third section for accessories. So accessories simply enter the quantities because we have a fixed standard values. For example, here in this project, I'm using this diffuser also there, no? Sealing diffuser, one number, right? And say I'm considering one VA box, for example, and one VCD also, volume damper. So enter the quantity, automatically get this value, this predefined values. So when you enter this, automatically at the end you will get the total pressure drop. You see, 1.07. First you will get in Pascal, and here you can find the conversion. When I click here, you can find the formula Q48 by 249. Now you can take 250. Q48 is here 268. 268 Pascals. 268 Pascal, if you convert it to inches of water gas, 268 divided by 249, 1.07. Got it online? Simple. So this exercise is very simple. You can use simply update the section information. You'll get the pressure drop for fittings, enter the quantities, and for accessories, enter the quantities only. Okay, and the value of this inches of water gauge, nothing but ESP can use in the formula to get the TSP, and using the TSP with the help of formula you can find the fan motor HP. Okay, so this concludes this fan selection also. But some theory topic like testing, adjusting and balancing filters, and this kitchen and toilet exhaust system. This topic you will get in the video. I'll share you tonight only after the session to download the link. And some advanced topic also you are going to get to download. I'll share you after this session only. And apart from this, how to access this estimation video course, I'll guide you on WhatsApp. I'll share you one link. You need to sign up and send me the registered email ID so that I can add the estimation course. And the estimation course you can access for complete 1 month. And it's a 10 hours course. Okay, you need to complete in 1 month, and with the supporting files, notes, project files. It's a 24 floors tower project. Okay, and that you can consider as a summary of this training program, because in the estimation course you'll get the chance to deal with a different system like ducting system, piping system with all metal specification, etc. So that is also interesting and important. And in actual practice, you may get a separate position for estimation engineer also. Okay, only with estimation also you can join as estimation engineer. So that is also important and useful. Even though if you don't want to join an estimation site, that will also help in designing and installation, because in that you will find the specifications and the material, systems, etc. with more details. Okay, so that is very interesting and important. I'll add that course. Okay, so done for this session and done for this live sessions. Okay, and if you have questions you can post in the WhatsApp group also. WhatsApp group will not delete. Okay, yes, Sunil? Yes.
Sir, how this chiller pipe is different from condenser piping, condenser line piping?
Means for sizing point of view or material?
No, from sizing point of view.
Sizing I cover one example. Na? You need to consider 10 FPS and the GPM will consider 1 TR equal to 3 GPM, the conversion. One example after this chill water pipe sizing we did for condenser side also. And the same air cooled chiller I take example as water cooled, and that pipe, so condenser piping is completely outside from the plant room, so we can consider 10 FPS velocity, but to find the flow rate the conversion is 1 TR equal to 3 GPM, not 2.4, because the condenser side. Sizing procedure is same, what we already learned.
Okay, means everything is same, only we have to take 1 TR equal to 3 GPM and
10 FPS.
10 FPS.
Yes, use the same pipe sizer and follow the same procedure.
Okay, sir. Sir, you have also told me that you will share the video related to selection of
Advanced topic.
Makeup tank.
Cooling tower, makeup tank, air separator.
Yes, sir.
It comes under advanced topic.
Okay,
so
sir.
Theory topic video and advanced topic videos I'm sharing right now. Immediately after this class. Okay.
Right, sir.
Okay then. Thank you for your cooperation online, and thank you for your patience listening these classes, and all the best for your future. And after completing the estimation course, you can apply for the certificate, and just send a message in the group. I'll provide the information. I'll provide the format. What are the information you need to provide, like your full name, date of completion for the estimation, and the photograph, so that admin can provide you the certificate after completing the estimation course. Okay.
Okay, sir. So it was such a great experience with you.
Thank you very much. Okay, so all the best for your future.
Sure, sir.
Okay, Mr. Shahbaz. Thank you.